Hey there, guys. Okay, how to model forces in this universe. So we've helped derive this universal force equation to explain how forces act on matter. Jumping into this third equation here, we've outlined these forces respectively, being from gravity, the force from electromagnetic light spectrum or particles, the force from the electric field, the force from the magnetic field, the restoration force, force from sound waves, and the pressure gradient here over time in a time series. And we sum all this up to equate the net force acting on an object or ion or particle over an enclosed area in flux, right? And so we can, this first equation here outlines the net force from a force acting on the velocity or vector of a particle, and some force n here, which could be any of these. And so the next step, we took the derivative of this third equation to equate this fourth equation here that states the force on an object is the vector sum of the derivative, the 3D derivative of the forces in the x, y, and z direction. That's what this upside down triangle means. And so, yeah. And then, of course, there's the fourth dimension of time as well. And so we can take the cross product of the object velocity multiplied by the force flux vector to yield the resultant force vector with direction and dot product for magnitude. And so we can use this force equation to help model how the forces acting on cells in various environments. With the key difference being that there's now this force from cell mobility, and that the pressure force is equivalent to the force from diffusion, or the hydrological gradient. And we can further ask, well, all right, which one of these forces are going to be more dominant on cell membrane and ion flow and movement, right? And we're still trying to understand the answer to that question. But we do know that these three forces here are have a more prevalent and dominant effect, being from the force from gravity, the force from cell mobility, and the force from pressure. Yes. And so we'll have to keep this in mind going forward, and we can really take this a step further. And I know a lot of us are space nuts here, and we can say, hey, well, how does this apply in space and microgravity? Whereby each force can be assigned a certain weight percentage value. And let's guess, which of these forces are not going to be as prevalent. So actually, it turns out that so the question is here: which forces become more dominant, upregulated or downregulated? And so it turns out we're actually at a lack of almost half of these forces. The force from gravity, mobility, electric field, the magnetic field, and the pressure largely are minimal or non-existent in microgravity. And so we'll have to keep this in mind in terms of how cells in a biological system are adapting. And also that in the lack of these forces, sometimes when they're artificially introduced, there is an increase in that force's susceptibility or sensitivity. Yeah. And so if we were to take this a step further and say, hey, well, how do these forces interact? We can come in here and do some calculus and derive the dot and cross product across various vectors dot product similar dimensions, cross product different dimensions. And we can take the, and so here's the resultant vector for the dot product for the magnitude and the cross product with the Jacobian for the direction. And across the time series, right? And so how does this apply to this force equation here? Well, here's what we came into, right? Energy tensors. These energy tensors can account for the interacting and combinatory forces, whereby a tensor is also just a 3D version of a matrix. And so we have this vector here, or force, and a force or vector here in another direction, right? And so we can come in here and say, all right, well, just starting with two of these forces with electromagnetism, we can take the force from the electric field, cross product with the magnetic field force, plus the dot product of the two, and here's something along the lines of what we would get from that that combination of those two forces alone. And then similarly, we can say, all right, well, how would this, how could we apply this to the universal force equation with the 7 forces? What would this tensor or matrix look like in trying to add up the combined effect of a lot of these forces? So, as astute scientists and researchers, the question here is which forces have a significant dot or cross product or combinatorial effect? Yeah. All right. I hope this helps. Thanks for tuning in, guys, and may the force be with you.